Record, here you go, record. Okay, so another one, number two. I'll call that number one. We'll call this number two. Two, okay. I have 2x plus y is greater than or equal to -4. I have x minus y is less than 4. I can't graph it the way it is. I have to get the y by itself. So what I'm going to do first is I'm going to do like a little scrap work, and I'm going to solve for y. So 2x plus y is greater than or equal to -4. I need to subtract 2x so I can get y by itself. Y is greater than or equal to -2x minus 4. So really, that's my real first equation. Y is greater than or equal to -2x minus 4. Because you have to get y by itself. Then I'm going to do my other equation. X minus y is less than 4. So again, I have to get y by itself. So I'm going to subtract x. Negative y is less than -x plus 4. Now you have to be extremely, extremely, extremely careful. We are going to divide everything by -1. When you divide by negative, what we have to remember, we got to flip the sign. I had to take that off. I don't have enough room. -1. So y, flip the sign, is greater than x minus 4. And negative x divided by -1 is positive. 4 divided by -1 is negative. These are my new equations. So let me write it down. Y is greater than x minus 4. Okay, so now we're going to graph it. Okay, we're going to start at -4. 1, 2, 3, -4. My slope is -2, so I'm going to go up 2 and over to the left 1, up 2 over to the left 1, up 2 over to the left 1. Anybody use the graph paper I sent that I put up there? Feel free to. It might make it easier to graph these. Okay, so then I look. Is it equal to sign? Yes, it is. So it is a solid line. Where does it say to graph? Above the line. So I'm going to go up. Now we're going to graph our second line, but notice it also has a y-intercept of -4, which is fine. So they both are going to cross here, basically. So the slope is 1. So up 1 over 1 to the right 1, up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Oops, up 1 to the right 1, a few more. Okay, and then down 1 to the left 1, down 1 to the left 1, and last one. Okay, now I'm going to look. It is not equal to, so this is my dashed line. This also has greater than, so I take a point and I'm going to go up. Where are they sharing the same section of this graph? They're sharing it right here. They're both are pointing to this section right here. And that's my graph of this inequality. Hey, before I do the next one, anybody have any questions? By the way, I have this cold, so if I'm sniffling, that's why. Hey, Kevin, Randy, I don't see you. Make sure you're in my camera. I can see you. Okay, I'm going next page, new page. We'll do some more of these so you see what they look like. Add page. Okay, now let's do one that's a little different. 3. Let's say I have y is less than or equal to 5 and x is greater than 1. They're very different. There is no x in my second one, so we're basically solved. I mean, there is no y in my second one, I meant. There's no x in my first one. All right, so let me get my graph ready. So this kind of problem, you have to remember what it means to be y is equal to 5. So you want to think of it as y is equal to 5. That means every y is 5. So every y is 5. So let's go 1, 2, 3, 4, 5. Every y is 5. I don't care where I am. Every y is 5. So it's a horizontal line at 5. It's also equal to, so it's going to be a perfectly solid line like that at 5. It says though to graph below it. So I'm going to take a point and I'm just going to put a little line to remind me below. And then x is greater than 1. So think about what it means to be x is equal to 1. It means every x is 1. Okay, so that means 1, 1, 1, 2, 1, 3, 1, -1. So it's just a vertical line, but it doesn't have equal to. So it's going to be a dashed line. Hey, my arrow I put in the wrong spot. So I'm over here. I just covered my arrow up. This is greater than. Now, greater than, when it's a vertical line, means the numbers have to be bigger, which means it has to be going to the right. What do they share in common? This whole section right here. And then I want to do 2 more just to show you. So number 4. Oops. 4x plus 2y is less than 8. And 4x plus 2y is greater than or equal to -8. Number 1, I can't graph that till I solve for y. So we're going to solve for y. So here's my box. I'm not going to do a bottom. Okay, so 4x, this is my little scrap work. Of course, I should see this on your test, right? So I'm going to subtract 4x, 2y is less than -4x plus 8. Divide everything by 2. Now it's a positive 2, so I don't flip my signs. Y is less than -2x plus 4. Okay, that's my new equation. Y is less than -2x plus 4. I can actually cross that out so I remember I did that one. Now we're going to do the second one. So 4x plus 2y is greater than or equal to -8. I need to solve for y, so I should subtract 4x on both sides of the inequality sign. 2y is greater than or equal to -4x minus 8. Again, I'm going to divide by 2, which is positive 2, so I do not flip my inequality signs. Y is greater than or equal to -4 divided by 2 is -2x. -8 divided by 2 is -4. So my new equation is y is greater than or equal to -2x minus 4. So we did our scrap work and we have our new equations. Let's put a graph. Anybody notice anything about these lines? They're special lines. Feel free to push your space button and tell me, what kind of lines are they?
Parallel.
Parallel. Yes, they are. Yes, they are. Why are they parallel? How do you know?
They have the same slope.
Same slope. Very good. Very good. So when I graph this, there better be two parallel lines. The first one, we start at 4. 1, 2, 3, 4. There's my y-intercept. Slope is -2, so up 2 to the left 1, up 2 to the left 1, down 2 to the right 1, down 2 to the right 1, a few more, down 2 to, especially without grid paper like the graph paper is. This is hard to do freehand. Okay, so now I look back. Oh, see, good thing I looked. It's not equal to, so it has to be a dash line. Wow, that looks really bad. Hold on. And it's less than, so it's under. So I'm gonna put a little arrow, just remind me it's under. And now we're gonna graph the second line, which starts at -4. 1, 2, 3, -4. Same slope, up 2 over 1, up 2, left 1, up 2, left 1. Up 2, left 1, up 2, left 1, and let me go backwards. Down 2, left 1, down 2, left 1. Now this says equal to, so this is going to be a solid line. This one's a little off. But it says greater than or equal to, so it's going to be up. So where they share, the space in between them. So all the answers to this inequality would be within this shaded region. That's what you're shading. You're shading where all the answers lie. All the answers are going to lie right in the shaded region to these two inequalities together. Okay, I have one more. Anybody have questions? Y less than or equal to -1/2 x plus 2. Y is greater, oops, sorry, not less, greater than, less than -3x minus 3. All right, so make a line. I don't have to solve anything. It's already y equals, right? Make our graph. All right, so I'm going to pause and I want you guys to try to do it yourself. And I'll put the answer up in a minute. See if you can figure out where the graph goes and where everything goes. Okay, I'm going to start graphing. Don't look unless you're done. I don't want to take up too much time about drawing. Don't look unless you're done, which I'm not done yet. So Oh yeah, finish my graph. So let's see how you did. And then I'm gonna ask any questions. Did we shade okay? That was a weird shading because they both were under. So you had to go where they both went under when they came together. Okay, no questions. I'm gonna move on. Just make sure there's no questions. You guys are all right. Okay. Very different topic. So we're gonna do 5-3 and 5-4. Separately, of course. 5-3 polynomials. Sorry, my handwriting is not too good today. Polynomials and polynomial functions. This is probably review. If you took developmental math 2, you did this already. If you're here and you haven't done math in a while, I'm sure you've seen this. Just need a little refresher. So first, we want to talk about the vocabulary. What does all this mean? So what's a polynomial? Now, I could give you a whole math term, but this is what it means to me. Many terms. That's what poly means, many. Nomial is a term. So many terms, many terms that are separated by adding or subtracting. One thing really important about a polynomial, not everything's a polynomial, but one thing we really have to talk about is that exponents must be positive. You can't have negative exponents to be a polynomial. All exponents have to be positive. When we write our polynomials, we're always going to write them in standard form. Will your online work make you put it in standard form? I don't know, but you should be in a very, very big habit of doing standard form. There are teachers who will take off if you don't put it in standard form, and I'm actually one of them because it's not the right end result. Okay, so polynomials should always be in standard form, which means polynomial should be written from highest exponent term to lowest exponent term. And we're going to put this all together after I talk about the definitions. I didn't even tell you what term is yet. Probably should tell you what term is. A term, each piece of a polynomial, each piece of a polynomial. And I'm going to put these three together with example. I'll show you what all these mean in example. That's a polynomial. It is different pieces that come together, many terms that are separated by adding and subtracting. That's a polynomial. It's also in standard form because if you look, the highest exponent is first and it goes down to the lowest exponent, which is no exponent. That's standard form. And each piece, this is my first term. This is my second term. Each piece is a term. This is my third term. This is my fourth term. This is my fifth term. So every piece separated by a plus or minus is a term. Questions so far? I got 3 more vocabulary things to talk about, and then we're going to put it all together, hopefully. Of course we are. What am I saying hopefully for? Of course we are. No, let me do this one first. Coefficient. Okay. It's the number in front of the variable for each term. So there could be many coefficients in a term. There's a very special coefficient which tells us a lot about, as you go on with math, it's going to tell you a lot about what the graph looks like. And that's called a leading coefficient. There's another reason why you want to put your polynomials in standard form, because in standard form, it's the coefficient that is listed first. Meaning it is with the variable, it is in front of the variable with the highest degree. Oh, sorry, exponent. We're not ready for a degree. Exponent. Just like standard form is highest exponent to lowest exponent. So if you put it in standard form, the very first coefficient, the very first number you see that's attached to the highest exponent is your leading coefficient. And I'm going to do an example for these 3 too in a second. I have one more thing to talk about, constant. Constant sounds just what it does. It is a constant. It's never going to change. It's not going to have an X, because once you put an X, I can put a number in for X, it'll change. So a constant is just a number with no variable. Okay, let's do an example of these 3. We'll tie this together this way. All right, so let's say, okay, so I have negative 2x to the third plus 3x squared minus x plus 2. It's in standard form. How do I know? Because the exponents are 3, 2. By the way, this exponent here, I'm putting it red because we don't write it. That's a 1 exponent, right? And then this would be a 0 exponent. There's no exponent. We call it 0 exponent. I'll show you why in a few minutes. But it's in standard form. So this is my leading coefficient. The first one. What are all my coefficients? All my numbers in front of the variable. I gotta explain one of them though. So all the coefficients are -2. For the x squared, it's a 3. For the x, which really has a power of 1, we still have that 1 that we don't write. So it would be -1. And believe it or not, 2 is also a coefficient. And you're going to say, why? It doesn't have an x. Okay, so it sort of kind of does. We just don't talk about it, or we don't write it. Okay, so let me erase this. This is a third power. This is the second power. This is a first power. That is the 0 power. A constant has a 0 power exponent with an x. But why don't we write it? Why do we just, how come we don't put 2x to 0 power? Because anything to the 0 power is equal to 1. So this becomes 1, and 2 times 1 is just 2. So we just write 2. We don't write this, but it's there. We just don't write it. So technically 2 does have an x to a 0 power after it. So that makes it a coefficient. So any constant, let me write that down too. Any constant will also have an x to the 0 power that we don't write. Do not write. If I tell you 12, it is really 12 x to the 0 power. If I say a third is a constant, it really is a third x to the 0 power. We don't write it because we don't need it. It just means 1. A third times 1 is third, and a 12 times 1 is 12. But when we start talking about polynomials and leading coefficients and powers and exponents, and we're going to talk about something called a degree in a few minutes, that's important to us. We need to know what that is. Okay. All right, there are different types of polynomials. They fall into different categories. Types of polynomials. Because when you name a polynomial, you have to be as specific as you can be. The first very specific kind of polynomial is called a monomial. Mono meaning one, so it only has one term. For example, 2x, 5, negative a third, y to the fourth. It's just one term. There's no adding or subtracting. It's one term. The next one is a binomial, bi meaning two. So it'd be two terms. So you should see 1 plus or 1 minus between them. Example, x plus y, two terms. I have one adding, x is my first term and y is my second term. I have 6y squared minus 2, again, two terms. 6y squared is my first term and -2 is my second term. Or we could have, we can actually put variables together. We can do like 3x squared y minus 4y to the fourth. That's also two terms, more complicated, but 3x squared y is our first term and 4y to the fourth is our second term. There's only one sign, a negative. We have a minus sign between the two terms. And the last very specific polynomial is a trinomial. with tri meaning three terms. So something, let's say example, something like x squared plus 4xy minus y squared. So you'll see two signs. I have a plus and a minus. It could be negative x to the fourth plus 3x to the third plus 1. Again, three terms. 8x squared minus 2x minus 14. Again, three terms, trinomial. Every other polynomial, meaning bigger than three terms, is just referred to as a polynomial. So if it doesn't have one term, two terms, or three terms, we call it a polynomial. You'll see words like classify this polynomial by the number of terms. Well, that would be, I want monomial, binomial, trinomial, right? We'll talk, the next one we're going to talk about is degree, and we're going to put this all together. So if it ever says classify this polynomial by the number of terms and it's bigger than three terms, it's just called a polynomial. Degree, this is a big one. You'll be talking about degree forever, math, degree. We need to talk about it in two cases. So I'm going to put a bullet. If there is only one variable, because sometimes we can have more, it's the highest exponent. So you know when you put it in standard form, it'll be the first one. Four x to the fourth plus 3x squared minus 2. This would be degree of 4. The highest exponent is 4. I have it in standard form. My degree is 4. It's the highest exponent. Now that's if you have one variable. It gets a little more complicated when you have more than one. So if there are more than one variable, you need to add the exponents. Add the exponents to find the degree. I'll show you what I mean in a minute. Say I have 5a to the fourth, b to the third, c minus 2a to the third, b squared, c plus 5. By the way, if I classify this by number of terms, I have a trinomial, right? Trinomial, 3 terms. But if I want to know by the degree, I'm going to add my exponents. Now, I'm putting this in red. This is really a 1. This is also a 1. So if I add my exponents for my first term, this term, I have 4, 3, and 1. So I have 8. If I add my second term to see which one's bigger, I have 3 plus 2 plus 1. That's 6. So my degree is 8. And that's what I mean. If you have more than one variable, you have to add all the exponents together to find your degree. I'll put a little thing here. Oops. No. If you have a constant, the degree is 0. Because if I have a constant like 14, I really have 14 x to the 0 power, and that would be my exponent, my degree. Okay, now I want to practice. We have all that down. I want to practice some classifying these different kind of polynomials so we can practice a little bit. I still see people writing, so I'm gonna wait a few minutes.
Yes, actually, I was calling to.
Okay, it looks like most of us are done. Let me see. I still see a couple people writing, so hold on one second.
And my lease ends.
Okay.
on the 31st
If I missed you, I'm
of
sorry. I'm trying to look at all the
August.
pictures.
What I have
All right.
to do to,
Whoops, that's not what I want to do. Blank sheet.
in
All right, so let's put it all together. Okay, so we're gonna put it all together. Okay, so, okay. First thing,
my policy
find
is
the degree
801
of each
1732.
term. So I'm just gonna give you one term. I want you to find the degree just to get started. So, A is 1, 5y to the third, 2, 10xy, and 3, 8. Now I'm gonna be quiet for a minute and I want you to see, write down something, see what you think it is.
Need,
Find the
make
degree
sure
of
that
each
it
one.
covers to the end of my lease, which is the 31st. Because I've had it for like 3 years now and it's always been on automatic, but when it came up for automatic renewal, I didn't.
Okay, we should have
because I wouldn't need it for
3
a
for the
year.
first one, degree of 3,
Weeks.
degree of 2, y, because x is the first and y is also to the first, and degree of 0. Because we really have x to the 0 power here, which is a degree of 0. How we do? Yeah, awesome. Good. I like to see that. If you didn't get it, ask me a question. I can answer it.
Until the 31st.
We're going to do some more problems too to practice. Okay, so
Yes.
let's do this. Classify each polynomial by the number of terms
Yeah, I have a
and state the
notice that
degree.
it's active until the
And
9th, and then it's
state
canceled after the
the
9th,
degree.
and that's only because I didn't elect to automatically renew it.
I'm gonna write them down again, and then you guys have a minute to try them out. And when I say classify by the number of terms, I mean monomial, binomial, trinomial, polynomial.
Okay, thank you.
We ready? Almost? No. I see people working, so hold on. All right, number one, I'm just gonna put a little notation. Degree is 5, and it is a trinomial. 3 terms. The second one, degree. Now, this is one where we have more than one variable, so I have to add them up. So x is to the first power, z is also to the first power. If I add up all those exponents, I get a degree of 4. And it's only one term, so it's a monomial. There is no plus or minus. It's a one-term monomial. Number 3, my degree is 3. Now, just a caution warning. I have these in standard form. If they are not in standard form, you have to write them in standard form first. Don't just look in the front and say it's degree of 3. I'll show you an example in a second. Now, it's 2 terms, so it's a binomial. And the last one is also a degree of 3, but it's 4 terms, so we call it a polynomial. I have something else I want you to do. List all leading coefficients from above. Okay, leading coefficients for the first one would be 4. For the second one would be -2. For the third one would be 1. And the fourth one would be -4. I'm going to underline them just in case you got them, you didn't see it. They're my leading coefficients. The first coefficient you see when you put them in standard form. I'm going to have you do one more thing before we move on, just to make sure we cover all vocabulary. List all constants from above. One, two, three, 4, and I'll move it down so you can see it all. List all constants from above. Now, if it's missing a constant, it's really 0. So number 1, the constant is -1. Yes, you take the sign with it. So it'd be -1. 2 doesn't have a constant, so it's just 0. 3 as well does not have a constant, so it's 0. And number 4, the constant would be the -10. You take the sign with it. And just to make sure, that's my constant. I think of it as plus 0, there's nothing there. Plus 0, nothing there. And then the first one is -1. Now, one more thing, just to make sure, because I'm writing everything in standard form. What do you do if it's not written in standard form? So let's look. Say I give you this polynomial. Oops, make this a 3. And then I'm going to put a list of things I want you to find. Degree, leading coefficient, constant. All right, there's 3 things I want you to find. Find the degree, leading coefficient, and the constant.
Okay. Now that was. If that's what it was under, yes, that's fine. I didn't know what we built it.
All right, degree, it's just not in standard form. So I do suggest rewriting it. You don't have to rewrite it to find this, but I would rewrite it in standard form. Exciate this first, and then I see next biggest power is 4.
Thank you very much.
And my next bigger power is 2, is a 3.
You were good. You have a great day.
And my next bigger power is the x. And then when you have it in standard form, then you just have to look for the answer. You could do it without doing standard form. So the degree was 8. Leading coefficient was -3, and the constant was -4. So always make sure they are in standard form before you answer your questions. I don't want you to go right to the front and go, oh, the degree is 1 and the leading coefficient is 6. No, make sure it's in standard form first, or rewrite it in standard form. Questions? Polynomials are sort of fun. We're gonna do a lot of things with polynomials.
I thought that you had said if there was a constant, the degree is 0. Is that not all? I'm just confused on that.
Yes, constant degree is 0, but the degree of the polynomial, so the degree of the whole polynomial is the highest exponent, which is 8. Where did I mess up? Did I mess up somewhere? So the degree, sorry.
Time.
The degree is 0 for a constant. So if I just gave you -5 and I asked you for degree, the degree is 0. And the leading coefficient would be -5 because really that. But a degree over a whole polynomial is just the highest degree. Or the highest power, let me put it that way. Is that okay? Did I answer your question? Anything else? Okay, now that we know the basis of polynomials, now we can do things.